Okay, consider this exercise. A block A of mass m equals 0.5 kilogram, 0.5 kilogram, lies on another block B, which in turn is sliding on a horizontal surface with acceleration equal to 1 meter per second square. Take cosine A or alpha equals 0.8 and sine A equals 0.6. For block A not to slide relative to block B, the coefficient of static friction, mu, equal to how much? Okay, such type of exercises. Block M, small m, which is a block A, is located on an inclined plane B, which is moving with a constant acceleration A. That means we are talking about block A is present in accelerated frame of reference. When we speak about such topic, refer to the introductory video that I spoke about it. فينا نطلع على such type of exercises in two ways. First way, viewing the motion from inertial frame of reference, هذا الobserver, inertial frame of reference, or second way, viewing the motion from non-inertial frame of reference. The observer will be within the accelerated frame of reference. Okay. So first of all, let's solve it from an from inertial frame of reference. Okay. First way. أول شيء عم نطلع الobserver بيشوف الموtion of a block M, small m. At initial position it was here, and then at final position it was here. So because it's located within or on the accelerated frame of reference, لأن ما في motion between block A and block B as the question states, for block A not to slide relative to block B. فمعناتها ما في عندي motion for small m صغيرة with respect to an inclined plane B. Thus, all the system عم يمشي بنفس ال acceleration A equal to 1 meter per second square to the right. Okay. هلا شو ال forces applied on M? This is M. Okay. هيدا normal force N. This is mg. This is the friction. فعنا هيدا acceleration. Okay. Okay. First of all, since mg perpendicular to the horizontal line and the y-axis perpendicular to the inclined line, then this is alpha, same this. Okay. And since acceleration in this direction also parallel, direction of acceleration parallel to the horizontal line, also then this is alpha. First of all, we can about the axis of motion. فينا نعتبر الاكسس اوف موشن عادة ناخدهم هن عبارة عن إذا بدنا نعتبر إن هيدا الواي axis and this is x axis. It's not x axis but we can consider it. There is no problem in that. This is x axis and this is y axis. Okay. So apply Newton's second law. Summation of forces equal to ma. Along the x axis we have since we consider positive direction to be with the direction of this is alpha, this is alpha, direction of acceleration, so this is a cosine alpha and this is a sine alpha. So we have plus friction minus mg sine alpha equal to ma cosine alpha. On y-axis we have normal force minus normal force plus mg cosine alpha equal to ma sine alpha. Now friction equal to mu n, and thus we can substitute, we can get n from here equal to mg cosine alpha minus ma sine alpha and substitute it in here. So we get mu into mg cosine alpha minus ma sine alpha minus mg sine alpha equal to ma cosine alpha. Then we get that mu equal to ma cosine alpha plus mg sine alpha over to mg cosine alpha minus MA sine alpha. Now we have all of these are given. M equals 0.5 kilogram and the acceleration equal 1 meter per second square. Cosine alpha equals 0.8 and sine alpha equals 0.6. So we get the answer is equals 0.91, which is D. We can solve the exercise from the second way, from observer looking within the accelerated frame of reference. Okay. Second way. Remember that in non-inertial frame of viewing the motion from non-inertial frame of reference, we need to consider pseudo-force, which is equal to minus MA as a direction, minus as a magnitude, pseudo-force F as magnitude, only equal to MA, right? Okay, we have this is M. Since direction of A this way, and the direction of force F is in this way, okay, which is equal to minus MA. We have also normal force N, we have mg, and we have friction. Now, concerning the axis of motion, you can consider any axis of motion you want. Like, you can consider this and this axis, or we can consider the usual axis that we consider in such type of exercises, which is axis parallel to NA, parallel to normal force. This is y-axis, and this is the axis of motion. Okay, you can consider anyone you want. And this is friction. Okay, this is alpha, and also this is alpha. So along the x-axis, we have, since the motion of a block, since we are observing the motion of a block A from within an accelerated frame of reference, and since the block A is not sliding with respect to the inclined plane, that means there is no motion along the inclined plane. So summation of forces are equal to 0, right? Along the x-axis, we have force, the pseudo-force F, along the x-axis part of it. Okay, that is projecting along the x-axis, I mean, plus the friction plus the mgx equal to 0. I want to consider that this is a positive direction. Then mg sine alpha minus the friction plus, we are projecting now, so the magnitude of F, pseudo-force F equal to MA. So we put the magnitude, then we put the direction is a plus because we consider it like that, okay? A plus MA cosine alpha equal to 0. That is mg sine alpha plus MA cosine alpha equal to mu n. This is the first formula. Second formula, along the y-axis, also summation of forces along the y-axis equal to 0. Why? As we said, that there is no motion between a block A and the inclined plane, as the question states also. So we have considered a positive axis is with direction. So we have normal force plus pseudo-force along the y-axis, which is MA sine alpha equal to mg cosine alpha. Then we get normal force equal to mg cosine alpha minus ma sine alpha. Okay, we substitute it in here. We get that mu equal to mg sine alpha plus ma cosine alpha over to mg cosine alpha minus ma sine alpha. The same formula we get by solving the first way. Ma cosine alpha plus mg sine alpha over mg cosine alpha minus ma sine alpha. Remember that the pseudo-force F as the direction equal to minus ma. But here we put that it is a plus pseudo-force because we consider the positive direction of the axis to be in the direction of the pseudo-force. I mean, this is the positive x-axis and this is the positive y-axis. And since pseudo-force in this direction, so the x-axis part of it, and the y-axis part of it are along the positive direction of the axis of motion that I considered. Okay, don't confuse in this idea. So in this exercise we spoke about studying the motion of an object within an accelerated frame of reference. We solve it using by two ways. First way, looking or observing the motion from inertial frame of reference. Then we consider since there is no motion between the block A and the block B, then all the system within the accelerated frame of reference, which is inclined plane, are moving with a constant acceleration A to the right. Second way, we observe the motion from non-inertial frame of reference. As we mentioned in the introductory video to such topics, you can check it in the physics playlist, that the block A, which is located in non-inertial frame of reference, it will sense like a fake force, which we call it pseudo-force, due to its presence in accelerated frame of reference, with magnitude is equal to mass of the object, which is the block A, multiplied by acceleration of the accelerated frame of reference. We get the same results, and here it is. Stay safe. If you have any questions, drop them in the comment section below.